Hey Techno Studs, in this video let's talk about DHCP and what happens when you first plug your laptop or your computer into a switch. So what we're going to be talking about is this connecting a computer to a switch. So if I scroll down here, all this section is just talking about this demo laptop plugging into this switch and what's going to happen with this demo laptop and the communication that will happen between the demo laptop and this server right here. This server acts as an Active Directory server, as a DHCP server, and a DNS server. So it serves many different functions there. So we're going to talk about what happens when you connect your computer in. Oh, first of all, you put the port configuration. So there's a couple things that happens from a layer 1 perspective. When you plug in in this case, the demo laptop, you plug in the demo laptop into a switch, and that demo laptop starts making a layer 1 connection with the switch, and it starts communicating with that switch. And there's some auto configuration stuff that happens with that switch. And there are several different things that are auto configured. And so some of those things could be the full or half duplex, the speed of it, or the switch could be sensing to see, is this an MDI that I'm connecting into, or MDIX? That means is this another switch or another MDIX device, or is this an MDI device that like a computer or a router that I'm plugging into? And some switches have the capability of auto sensing that. So these could be settings that are automatically negotiated, or they could be settings that are configured on the switch port, and the machine doesn't really have much choice on what it's going to take when it plugs in. All right. Next up, we've got the DHCP process. The DHCP process is this interchange that happens between the DHCP client and the DHCP server. And so what happens is you have two devices, a demo laptop in this case, and the DHCP server. And the demo laptop has a DHCP client that's running on it that recognizes, hey, I need an IP address. And the DHCP server is a service that's running on the server. So they're actually the DHCP client and the DHCP server. If you opened up on each one of those machines, opened up the services, you would see them, DHCP client, DHCP server. And so they need to make a connection back and forth. The client needs to request information from the server. So what it's going to do that is it's got to form a connection between the two, a network connection between the two. Okay, so DHCP Discovery, what we're going to do is we're going to open this up, and here is that application layer, the DHCP client, and the application layer DHCP server. Those are the two things that need to communicate together. And so in between here, we need to assemble our layer 4, our layer 3, our layer 2, our layer 1. So from a layer 4 and 3 perspective, I'll open this up, and you can see that it's UDP. So it doesn't make a TCP connection. It doesn't need to establish this connection because it's all UDP. So it is going to connect on port 68 and 67. So the source port is 68, the destination port is 67. The protocol is UDP, and the source IP address is 0.0.0.0, which makes sense because it doesn't know its IP address yet. And the destination is going to be a broadcast address. So this is going to broadcast it out. And any DHCP server, because you could have multiple ones, will be listening on there. All right, so when it sends this out, it's going to send it out on the Ethernet connection. It needs to know the MAC address. So we, in prior video, we went through this and it was pretty in depth on figuring out what the MAC address is, but it's pretty simple on this one because it's a broadcast. And so since it's a broadcast, it's just going to be all Fs. So it really is pretty fast to determine what the layer 2 address is. So it creates the frame, the layer 2 and layer 1 here, all Fs here, and the source MAC address is the MAC address of the demo laptop. So you see here, this ends in EEDD. So EEDD. So it's just using its own source MAC address, and that's important for this process. So, and then it goes through the switch processing. I'm not going to get in depth into that because we already took a look at that. And then frame disassembly just means it gets to that other machine. It opens up and starts looking at it. It takes a look at the MAC address, make sure is it destined for that machine. In this case, it's the server right here, and it does a frame check sequence or the CRC on it to check it to make sure everything is accurate. So does that Ethernet processing and layer 3 and 4. So it hands it up to layer 3. Layer 3 does the check on it and checks the IP, checks the CRC, everything looks good, and then passes it to layer 4, and it looks at the layer 4. So it goes through this process, and then it gets handed over to the DHCP server. Now, the DHCP server has some sort of scope on it, a range of address. The scope is the range of addresses that it can hand out. Perhaps it has some sort of subnet, well, it would have a subnet mask that's associated with that because it needs to hand out a subnet mask. It could possibly have exclusions, addresses that within the range that it doesn't want to hand out. It could have some sort of reservations. If a certain MAC address reports in and asks for an IP address, then maybe it hands the same IP address to that MAC address every time. And so that's a reservation. It has some sort of lease time. How long can this device keep that? And then it has some options. Things like default gateways, DNS servers, domains, phone gateways, lots of different options that we can have with this. And you can actually create custom options as well. So that is the DHCP Discovery packet that's being sent out and the application that's accepting it, that will process it. All right, so then that application then needs to create a response. So the application creates a response to respond back. It will create a layer 4 and 3 to it. Notice the source and destination ports are reversed on this one compared to the last one. And then it has a source IP of 10.1.0.3 because that's the IP of the DHCP server. And then the destination IP address 10.1.0.150 because that's the IP address that it's actually offering. All right, so then it's going to go through that Ethernet process to send it back. There's very similar except for the frame assembly, it actually is a direct message. It is a unicast here. It's not sending a broadcast out. And that's because it knows the destination MAC address. The MAC address was sent with the request, and so it knows the MAC address, so it might as well send it directly to that machine. So other than that, most of that processing is the same. They'll go through the layer 3 and layer 4 disassembly when it gets over to the other side. And then the DHCP client says, yay, I've got an address. That's awesome. It could actually receive multiple offers and then have to choose one. And so if it has to choose one, then, well, either way, it's going to send out a DHCP request. It's going to send out a DHCP request saying, hey, I want this address. So it goes through, once again, that application is sending it out saying, hey, I want this address. From a layer 4 and 3 perspective, it is a broadcast again. It doesn't officially have its IP address quite yet, but it sends it out as a broadcast. That way, any other DHCP servers that are out there know that, oh, it's accepted this IP address. And then it goes through that Ethernet process to get this once again to the server. And this is a broadcast, so it already knows the MAC address and goes through that the Ethernet process, and then unpacks it once it gets over to the server on the other side, unpacks it very similarly to how it did it before, and then makes it to the DHCP server service. All right, then that DHCP server service then sends a acknowledgement back and goes through a very similar process to send the acknowledgement back. Once again, it's going directly to the machine. It knows its MAC address, and so then that completes this process. So that is the DHCP process when it actually looks like. If you drilled into some of these, if you're using the tool as well, there'll be Wireshark examples that you can actually go in there and see what the data actually looks like. So it's a great tool to go in there and drill down to see how this process and what the process looks like. We'll briefly mention the other processes. There are other processes that happen as well, things that reach out, make connections. And one example of that is this network connectivity status indicator, which is one of the Windows machines that go out and test to see if you have an internet connection and just test to see that. If it doesn't, then it will change the status indicator to show that you don't have a connection to the outside world. So there you have it. So there is what happens when you take the computer and you plug it into the switch and some of the processes that happen around that.